Hello explorers and welcome to another video. Today I'm gonna talk about some kind of basic math theory that I didn't have that good of an insight into, and I actually had to learn the other week in order to figure out a problem that I had. And it's when you have a problem that involves some kind of theory, you need to have a way to think about it and get your solution. So my problem was that I had, let's say, a number of points, or let's say we had a shape like this in some way, and then I had some shape inside of this shape. And I wanted to know if this shape was inside the shape or if it was outside of the shape. And I was thinking a lot about how to find different relationships between different points and relationships between the shapes. Maybe I could look at, for instance, the different length between different things and figure out what this thing, where this thing was situated and so on. And then I had a talk with one of my colleagues, and he gave me a lot of different insights into simple math theory. So first off, we talked about if you have a straight line, let's say we start with a point. So in a point, if you know that you are inside a point or outside of a point, well, you just have to look at the actual point. Is the point, are you inside the point? Yeah, you are at the point, because you can't be anywhere else. So if we now take a line, for instance, we have like this, then I need to be somewhere on that line in order to be inside of the line. So these things are quite easy to figure out. And one other thing that I had to know about was that if I put this line into a coordinate system and put the point at origo, so let's say that we had a line that started from 1, 1 and went to 2, 2. So that's x1, y1, y2, x2, y2. So we have a line that goes somewhere from origo. Then I need to divide, or need to subtract the first coordinate with the second coordinate. So 2 minus 1, for instance, 2 minus 1, and then if I do the same here, you get origo, and you end up with a point at 1, 1 that goes from origo over there. And that will have the same angle. The difference is that it starts at origo. And if you have one of these, then you have some sort of a vector with a specific direction. And that was something that I needed to know about in order to solve this problem. At least the way I solved it. Because if you are on a line and you get outside of the line somewhere here, then you have an angle somewhere here that is larger than 180 degrees. And that was what I figured out. So if we have something inside of here, and we draw all the lines we can find from the different points of this shape, so all these lines from all the end points, and we'll look at each of the angles that I got here, and none of the angles are larger than 180 degrees or 1 pi, because when you are calculating in some coordinate systems, you might get it in from 0 to 2 pi, or from -1 pi to pi, which you do in Java. So if you use the function a tan 2, it will give you some number from minus pi to, so let's say, give it an arrow there, to another pi. So somewhere in between there you get a value. So I used this function, I figured out all the different angles I got between these values. I measured all the angles I got from the different, and then picked the largest one of those and checked it against 180. Because if you are on a line, you have 180. If you are inside, you have a little bit less. And if you're outside, you have a little bit more. So let's say that I have a point over here, and see if that is inside, and I draw lines to everything here, then I will have some kind of angle over here that is a lot larger than 180 or 1 pi. So per definition, if I have a point where the angles to every other point are, I don't have an angle to any of the other points that is larger than 180, then it's inside, or 1 pi. Or if I have one angle, just one angle between all the other points that are larger than 180, then I am the side. So that was what I figured out, and what really helped me to realize how to figure out if a shape is inside of another shape or outside of another shape. You can do a lot more if you need a more fine-grained thing. For instance, in our case, we had some shape that went something like this, and then we had some other shape over here, and we realized that it's, in our case, if you could have one point in between of all these points that are a little bit inside of the other part of the other shape. So we were ending up looking at an angle of 90 degrees or half pi. But I think this was something that was really interesting and something that helped me a lot to think about shapes in space, in a 2D space. So I hope that you found this interesting, that you learned something from this. If you have a better definition about how to know if a shape is inside of another shape or outside of the shape, then please tell me in the comments. I will read all of them and answer them. And if you haven't subscribed yet, do that. And I really hope to see you in the next one.